The next slide shows you some data taken from a study in which people were kept awake for nearly 100 hours. That may sound like torture, and I think for many of the subjects in that particular experiment it probably felt like torture by the time they'd been up for nearly 100 hours. But what you can see is the way that those two drivers of fatigue, that is the daily variation in the body clock or circadian system and prior wakefulness, work together. So you can see across the day that fatigue goes up and down, but in the long term, over the 4 days, that there is a long-term trend. So you will see fatigue go down and up and down and up and down and up and down across the 4 days of the study. By the time the individual reaches the end of the study, it's certainly much lower, even at the most alert time of the day, than it had been at the start of the study. But conversely, you can see that there are certain points where you can stay awake longer but be more alert than you were at a previous point, particularly where you are at the low point in the body clock. There's been a lot of research done over the last 20 or 30 years in terms of how time awake and time of day interact to affect fatigue. And if you look at the consensus values that come out of the research over the last few years, then most people will say about half the system is driven by how long you've been awake, and about half of it is driven by the circadian or biological clock. So this creates a number of very important outcomes for managing fatigue out in the real world. The first is that most of our enterprise agreements and most of our regulations around fatigue are based on the simple assumption that the more fatigued you are, the longer you've been at work, or vice versa, the longer you've been at work, the more fatigued you are. But in actual fact, if you think of the graph that we showed you previously, somebody was at their maximum level of fatigue at 5 or 6 o'clock in the morning. And as a result of that, extended wakefulness, by the time they got to 12 o'clock in the afternoon, they're actually much more alert. This carries some very practical implications. So for example, if I was to extend a shift from midnight till 4 or 5 o'clock in the morning, fatigue would go up very significantly because it would reflect the combined effect for being awake longer and reaching the low point in the body clock. On the other hand, if I finished a night shift and extend the shift until lunchtime, actually, even though the shift is longer, that person's level of fatigue will not necessarily go up. This complex interaction between time of day and time awake carries significant consequences in terms of how you would actually manage fatigue in the workplace and how you think about the different shift patterns and the options for extending overtime that may happen in your particular workplace. We'll go into this in a lot more detail, and most importantly, there are now quite sophisticated software programs that enable you to model these phenomena without having to think about it all in your own head. But nevertheless, it's important to understand that it's not a simple linear relationship.